Draft physics video presentation and such. Moment of silence. Anyway, I think maybe the instantaneous moment of thing is the spooky motion at a distance theory. Whatever that means. I mean, I just can't make any sense out of it. Nothing. Nothing. It's just, no, instant. Spooky action, you see, is a kind of a derogatory title. So nobody would call the action at a distance theory, because that makes it sound stupid. So the whole point of physics is to do the physical thing, to explain why things act. Now, the fact that the spooky action happens kind of slowly, okay, like it doesn't happen instantaneous, there is no evidence of that, real evidence, kind of indicates there's a process, that something takes place, something goes from point A to point B and conveys the information, okay, and the information in this case is, movement, force. So, but yeah, I just don't know what the hell you're talking about. I'm going to delete it because it's, whatever it is, it's incomprehensible. I don't know. All the comments are, not very well written, frankly. Great introductory words, says you. Rules, laws are made to be tested. Okay, that sort of goes without saying. Somebody says they're going to pass a law and the law is stupid, then yes, that's the test. Oh, that sounds stupid. No, thank you. I really don't want the law against me being me, so fuck that. Broken and changed if new evidence. See, that's the tricky part. So right there I stop and I say, this isn't about new evidence. It's about the old evidence. It's about any evidence. It's about conclusions drawn. It's about writing something in stone when you should keep it in pencil on paper. Okay, you shouldn't even write it in pen. And you certainly shouldn't be writing it in stone. So that's the whole problem. So you can see conclusions that are prematurely established. And you should wait for more evidence. The end of the trial should be, well, let's wait 6 months and see if they can find the video of OJ wearing the gloves and the shoes. Yeah, so why don't we wait for that video to show up and then continue the trial? That would be the smarter way to do it. No, but in that case, again, it doesn't really matter, right? Because the evidence is that the conclusions will be drawn regardless of the evidence. So that's part of the problem here, is that people have this impression, or we are raised to have an impression, or the Piros of the world will tell us that these jurors, the scientific community, is without fail. They're so disciplined and so careful and so thoughtful. They're just the perfect jury. And they never do anything stupid for stupid reasons. They don't carry any biases at all. Yeah, bullshit. They're just in many ways worse than the common man because they're nerds. Okay, they're math geeks. What evidence is it they've ever even touched a mechanical device, let alone understood it? So why should we assume that this jury has reached a disciplined decision when it has declared a judgment? Oh, that's right, we shouldn't assume that. We should pretty much assume the opposite. There's plenty of evidence of these bold errors. And even in physics itself, you can see their resistance to fix anything. The whole verbiage is broken. Benjamin Franklin, and an innocent mistake, assigned plus and minus backwards, because of a lack of information, and they never even decided they should fix this. The fact that there's 74 different ways to describe what energy is, a form of it. You got all these different scales and all these different kinds, a Newton versus a gram versus a ton versus a blah blah blah. I mean, it's it's full of evidence that you can't take it too seriously because it really wasn't that careful a decision. So it's not about the need for new evidence to save the day. But clearly new evidence would, in some sense, like they actually do point a satellite someday at the corona of the sun and see if they can take a picture of this lensing phenomenon, okay, that frankly they've never proven happens. No, that might be new evidence, but I'm just saying the existing evidence. The existing evidence tells you the lens is exactly the wrong shape, and it seems pretty bizarrely coincidental that you could take the wrong shaped lens, put it billions of light years into space, and somehow get the right image. It just doesn't seem very probable. And that evidence already exists, and they don't care. The evidence in the slit experiments, the fact that it is so marginal, so slight, a similarity. It's just like, or it seems like. No, it's not really. Not even that close. So really, this is about how evidence is treated, what people do with evidence. So, like I always use the OJ example just because it's just so grotesque, in the sense that no other human being would survive that mountain of evidence. No other human being that wasn't a celebrity. And it was just so obvious that our standards are completely different for celebrities, and the fact that we can't trust people to be on juries because people are lying scum. But anyway, that's sort of beside the point. It's so. All right, so that's I've already made my point. I think maybe excessively snarkily, but regardless. All right, broken and changed. If new evidence is presented contrary to what was previously established, so everything that was previously established is previously established in just a kind of weak and lame manner. No better than, you could say Trump said so, or Obama said so, or some kind of bullshit like that. There's just no good reason. So they have accepted things as doctrine, based on really poor circumstances. Again, Einstein's theory had no validating evidence until Eddington showed up with his bullshit experiment, and it was bullshit. I mean, it was overtly bullshit in that Eddington knew that it was a marginal experiment to start, and he knew that he got really horrible data, and he still sold it as a legitimate experiment. And somebody else should have pointed out how it really wasn't. You have a marginal hope of getting the right answer to start with, and then everything that can go wrong goes wrong. I mean, you're basically looking through a broken telescope, and you still say you got good enough evidence to establish something as a truth. Well, anyway, dogma provides no process for change. Well, again, it all depends on what you're calling the dogma, right? I mean, religious people don't care about reasonable doubt, and they have a concept called faith. They don't need any evidence, so they're already completely obnoxious to reasoning. I mean, belief without reason is what faith is. So they're obnoxious to it. So we shouldn't even have to worry about dogma in science, because frankly, they shouldn't have belief without reason. They shouldn't be doing faith things. They shouldn't be dogmatic. And you can see the dogma playing right in our faces, in the sense that they have tiny shreds of evidence, and they tell you, they'll tell you they took a picture of a black hole, when, come on, get real. It's so distant from what the word picture means in any traditional sense. And, LIGO says it can measure half the distance of a proton, or some other preposterous thing that has nothing to do with any theoretical rationality. Just has to do with, well, if all of their crackpot notions about how interferometers work is true, then maybe it could do that. But none of that crackpot shit is true. So I don't know I don't know if it can be called dogma. It's well, whatever. It's close enough, I guess. The scientific dogma lines were spot on. I don't know if I even used that term, but okay. Who is testing the so-called laws anymore? Well, the fact is there's no, they don't have to face a crowd, you know, in the audience going, that's a piece of shit, that's a lie, that's garbage, that's weak. You can't do that. You can't tell the jury that that's a, you know, you have fingerprints. You took fingerprints off his sink. You didn't take the fingerprints off the gun. You know, some kind of obvious thing. And there's nobody checking up. There's nobody scrutinizing all of these bad assumptions that they keep piling crap on top of. All right. Who is creating new theories? See, I mean, you know, it's not about creating new theories. It's about the word testing used right from the beginning, right? So the whole point is that they're just not testing the theories that exist. And, you know, so I don't know what to say. New theories just sort of means, you know, obviously if you don't have the answer yet, you're still looking for one, and that's the important part. So you start thinking about different ways to model it and redo it and figure it out. But if you've assumed you've got the right answer, then yes, you're not going to do that. And that's the information gap. That's the thing missing, is none of them have any will to start at the beginning, okay, and draw a picture and see how bad the picture they've drawn conventional science is in terms of how convoluted it has become. All right, so who's creating new theories for new laws or changing the old laws? So I don't know if any of the laws are really in jeopardy, the ones that are actually stated laws. I mean, Heisenberg is stated sort of as a principle, so they haven't really said the Heisenberg law. You know, so, you know, and laws like the inverse square law are really solid. You know, they're solid mathematically, they're solid in terms of the evidence, they're just solid. Still listening to the rest. Okay, well, whatever. Comments should always be after you've watched the video, but whatever. So, where do we go when, well, I think it's when, we die, then. So, you know, this is just, you're just saying nobody can be this dumb. I mean, how can they post a comment like that on this video? It's like, you know, it's just so baby talk. It's like, what do you think, your brain goes somewhere different than your foot? I mean, if I cut your foot off and I throw it in the garbage and it goes in a garbage truck, where do you think your foot goes? It goes to the dump, it rots, it decomposes, and it disappears as anything we really know about. I mean, someday there'll be a little daisy somewhere with, you know, pieces of your foot in it. But, you know, what do you want me to do? You want me to tell you where every one of the molecules inside your body is going to go? Every single little atom? You know, where every electron is going to go? Well, it's going to go back into the shit, the flow, the crap. Anyway, I sort of said that. I said, you're just a physical machine. That's all you are. You can have delusions about all kinds of other bullshit, but that's all that's happening. Your brain is an active machine. It's making a visualization, you know, a little picture. It's showing itself. Okay, yeah, it's kind of funny, I know. It's, oh, what do you mean it's showing it? It's projecting a movie to itself? Yes, that's how it works. It makes the screen, you know, it projects the movie onto the screen. So that's what's basically happening. I'll go a step further and say, yes, you're in the room watching the screen, but the point is you're not doing anything. Your brain's doing it. All right, that's it. It's a mechanical device. It's you're a robot. You wouldn't ask silly questions like, where does my fax machine go when I throw it in the garbage? You know, you wouldn't ask the question. It's stupid. But you think you're mystical and magical. Okay, fine. You're retarded. You're not only stupid, you're fucking retarded. You're ill-informed. You're delusional. You're just living on a bunch of wishful babble, little baby talk. Grow the fuck up. Alright, anyway. Your mass is mostly water, and most of you will likely just evaporate. So that's the easy one, right? The rest of you is just dirt. The rest is just dirt. Pretty much. They're just compounds. You know, a certain amount of sodium, and a certain amount of magnesium, and a certain amount of aluminum, and a certain amount of all that crap. That's all you are. And so you're just going to be mud in the wind. So, yeah. That's the idea. You're just going to be, you know, depending on how, look, you know, people sometimes get put in steel boxes, and, you know, it takes a long time for their stuff to get back into the world. And then other people, you know, you just throw them in a furnace, and they leave as, you know, pieces of matter and float around out there as water molecules and as little pieces of floating debris, and you know, there's some ashes left over, and some people put those in jars, and so yes, until the jar breaks, the ashes will be lingering about. Whatever. It's just so depressing. Human beings just, you know, it's so, like I said, I just think I can't, you know, it's a point where you're just saying, okay, you know, you play this game and you say this pathetic baby talk about this silly nonsense, made up little stories, and people cling to this crap. Hello, really like your talk, that's for, why do you have to hyphenate your? But anyway, or whatever that is, one of those thingies. Punctuate. Anyway, there is no argument about the speed that fluctuates. Anyway, between physical mediums. There's an argument about what you're even saying, comma, but for example, we assume that the speed of light near Alpha Centauri is this. We don't assume it. We deduce it. Everything else works the same. The other forces of gravity, things like that, are all working the same. We can experimentally know that the gravity pulling the moons of Saturn towards Saturn is just the same kind of gravity that's pulling our moon towards us. There's absolutely no good reason to assume otherwise, to have any doubt that the forces are consistent, because we have corroborating evidence, watching other things interact with each other, that there is the same mechanism and it's functioning the same. So there's no good reason to assume differently. It doesn't help in any way. So what? I assume the speed of light isn't consistent on Alpha Centauri. How does that explain anything about the world we live in? Oh, that's right. It doesn't do any of that. It doesn't create any kind of useful theory. It's just, see, this is the bizarre example. These people will not be skeptical of the things they should be skeptical of. Their fantasy theories of gods and mysticism and spirits and souls. That should be incredible nonsense. These silly stories, these UFO stories, that they should be skeptical of. And what are they skeptical of? I don't think my water's wet enough. Yeah. The government's conspired to make my water dry. Fuck. Sorry, yeah, I'm just having a bad day. It's just hard to take it. You're imbeciles. Alright, is the same as the speed of light here on Earth. Well, again, there's reasons to deduce it. There isn't reason to assume. Assuming is not really the point. The point is what does the evidence indicate? The evidence indicates, first, I don't have any reason to think it's different. Second, there's all kinds of evidence indicating it's the same. What I'm saying is, oh no, you're not saying anything reasonable. We just assuming it. Says you, the uninformed lunatic. It's not just being assumed. Again, there's lots of evidence. You just don't care to know any of it. Okay, we don't know about that, right, do we? Question mark. Yeah, we do. dumbass. The facts are that we cannot know. Fuck you, telling me what the facts are about how we can't know. You know, this is another idiot. We can't know, and that's the truth. And how did you know that truth? Fuck. What is going on everywhere in the universe? Well, no one's claiming to know everything that's going on in the universe. The point is the universe isn't that complicated. It's not singing and dancing. And there's cause and effect reasons why things happen, and we sort of have some of those nailed down in terms of certain interactions between charges and certain interactions between gravitational bodies. Now, they haven't figured out it's all the same thing, just slightly different manifestations of the same thing. But it's, you know, even their silly theory doesn't need any more moving parts. So we cannot determine that the speed of light, electromagnetic wave speed, so again, that's your assertion, okay, there's no reason to believe it's a wave, but whatever, or that it has any electric or magnetic component. It doesn't have any, okay, there's no, can't bend it with magnet or electricity, so why are you saying it is made of that shit? Is constant. There's every reason to believe it's constant. Every experiment ever conducted comes up with, generally speaking, the same very fast speed, and it's just, again, you're doing it for a reason. You're trying to break that truth for some dopey reason that's completely escapes a reasonable person's understanding. How does a variable speed of light do anything at all interesting? If it was, even if you could make it happen, what would it do except make the whole idea of a consistent universe nonsensical? And what good would that do you? I mean, to pretend that, well, somehow if we change the speed of light, okay, we change the pressure on atoms, we change how much they move, you know, the sun isn't hot anymore then, you know, all kinds of things change. Why would that be necessary or in any way useful as a thought process? But anyway, there's no point. What if water's not really wet? I mean, you know, like on Venus, the water isn't wet. Fuck you. As a matter of principle, this should be taken into account. For what purpose? For what use? Let's just pretend things aren't what they are. Okay, the cup I'm drinking out is really could be an elephant. How does that help me at all? What use is that silly imagination? All right, since it is logical from the lack of evidence. So again, there's a ton of evidence, so there's no lack of evidence regarding the consistency of the speed of light. So again, what kind of truther loony are you exactly, and why are you saying this crap, and why do you think I shouldn't want to just run you over? Because you're just so fucking stupid. Jeez, we can assume different possibilities. Fuck you. Again, it's not about what you can assume, it's about what you can argue. Can you argue anything reasonable? Can you explain how any of this would solve any problem or unify physics by breaking the speed of light? How does that fix any problems? It's mush. What if light is emitted from someplace near us? What does that even mean? Maybe emitted from the center of the earth. And maybe is emitted from life. So this is really, you're just insane, right? Oh, okay. So, yeah, maybe I shouldn't be reading it because you're insane. Maybe there is a million more possibility. Yeah, maybe you should just eat some shit and die. Oh, God damn it. Maybe after you laugh for a few seconds, you will... Now, am I laughing? You're just so fucking depressing. You fucking lunatics. And this is one of these breeding assholes, right? I mean, it's got an icon with a kid in it or something. Yeah, this is a breeder. This fucking idiot is breeding. Fuck. Alright, completely unbelievable idea as it can dismiss some paradoxes in quantum mechanics. How so? How does breaking the fucking speed of light fix anything? Science is not a game in make-believe. Well, you're living in make-believe. Your delusions are useless. You don't understand science. You don't understand the process. You don't doubt without a cause to doubt. There's no cause to doubt the speed of light consistently. It's just, there's no reason to doubt its function, its properties. It has properties that are pretty well established. And you're an idiot. That's pretty well established. Love and light. Fairy princess to you too. I hope she's driving a steamroller. Look at it, it's even written in this fucking shit, bullshit foreign crap. Ugh. Muslims. Shit. We'll just remove it for now. Oh, God, I'm so depressed. It's just so bad. Alright, anyway. Buck up, Gary. Come on, be a man. Alright. Well, Perv Action, who hasn't been too good lately, but let's see. Besides sheer mass, is there currently a technology around we could set up multiples of to degrade photons enough to get something like a gravity beam? So what you're not understanding, I don't know if I really need to draw a picture of it, but we'll see. Alright, give it a try. So you're really not getting something fundamental here. The Earth is really heavy. And gravity, this incredibly weak force, is moving the Earth. Okay, it pushes it, towards the sun. I wish this glare thing, I gotta figure out how to fix that. That is problematic. Let's see if I tilt it that way. It's very inconvenient though. Then I can't see what I'm drawing. But anyway, so I've pointed out that if I wanted to even just move this piece of chalk with photons, it would take an insane amount of energy to move it as fast as gravity will, with as much acceleration. So you have to understand that gravity is about 9 times 10 to the insanely big number thing. Oh, I put it down here. I should put it up here, right? Like to the infinity. Okay, more dense than a few little photons. Photons are a tiny, 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 tiny percentage of the energy in the universe. Okay, photons don't move planets. Photons don't do much at all. They give you a little 1,000 watts of little heat here in this little spot. I mean, a tiny amount of energy. Where you need a huge amount of energy, okay, to move Earths and moons and all of this stuff. So, obviously, even if you could, theoretically, I mean, it's good that you've at least figured out that, as I attempted to point out, that photons, okay, as traditionally understood, I'm going to draw the wave, okay, the silly wave. I'm going to draw it as just little lumps, okay? So just imagine these things as these things, alright, separated by a distance. Oh, that's really terrible. It doesn't show up at all. Let's try another color. Alright, so this was a wave here. Yeah, okay, you can see that. Disappointing. This doesn't work as well as I hoped. So anyway, so photons are just this stuff, and then I pointed out that it's quite easily deduced, okay, from facts that that we've gleaned, that our eyeball can only see this if there's 6 of these things, okay, and that we can make detectors that might see frogs might see only 4. So you only need that one that's 4 long for a frog to see it, where a human needs 6, and then we have instruments that maybe can see 3. We have instruments that probably can just see 1, but the problem is, see, that's where my point is. So if we make such an instrument, it's going to see it everywhere, because the amount of radiation is so dense that it's going to just be flooded. So it's like having a light so bright, you know, it just floods your retina and you can't see a damn thing. So the instrument becomes useless in terms of it can't see any detail because it's just seeing too much. So then you start having to make apertures and, you know, control how much light gets in, and then you're controlling really what angle it comes in at, and so that gets a lot more complicated. And you start talking about focuses, and that gets even more complicated, you know, because you know, just to see, you know, this optic stuff is sort of important. See, I mean, because, you know, you can bend light, you know, it's coming in parallel, and you can bend it to a focus, or you can bend it past the focus, you know, and create the image upside down kind of thing. And that's really what our eye does, right? It doesn't go to a focus, it goes past the focus. You know, and, you know, those are sort of things to understand with this whole lensing crap and everything else. You kind of have to understand these subtle details. This is not as simple as they want to make it. But anyway, so your argument is could we take the tiny percentage of light that comes in big clumps, right? So there's, you know, a bazillion of these little ones, and there's not too many of these long ones. Okay, so obviously the amount of light that we're seeing is a percentage of what a frog sees. A frog sees much more, and so it collects photons much more efficiently. So its little aperture hole has to get much smaller than ours because its retina is much more sensitive. So, but I'm just saying this is a tiny percentage of the energy. So even if you could break these photons into pieces, you know, and just turn them into 3s instead of 6s, what have you accomplished? Because it's still a tiny percentage of the amount of energy. There's already a billion of these to 1, you know, so you can't convert this weak photon into strong gravity because it doesn't have any density. So big photons are, like I said, it's a, you know, obviously it's not 10 to the infinity. I mean, I was exaggerating, but it's a tiny, 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 minuscule percentage of the energy in the environment is in the form of big, giant photons. Okay. And the other problem is the equilibrium problem. They're coming from all directions. You can't take advantage of a force unless the force is only moving in one way. You know, it's like the water's not falling in the atmosphere. You can't take advantage of it. You know, it has to be going one way. And the force that all of these little bits are in is coming from every direction. So there's no one side to take advantage of. Okay, degrade photons enough to get something like a gravity beam. So it's an interesting question, and I shouldn't be too patronizing in pointing out that you're just not getting it, that photons don't account for a very high percentage of the energy in the universe. It's just a tiny, tiny, tiny percentage. Visible photons. I'd imagine that something like that ancient Greek mirror weapon, only with not even heat energy. I don't know. I mean, I don't see how it. You know, the mirror thing is the idea of just collecting a whole. Again, it's a lens thing. A bent mirror is the same as a lens. So the mirror thing, okay, is just taking advantage of the fact that you can bend a mirror and focus the light. So you can take light from a large area and put it on a small area. Alright, I think a conclusive enough miniature of that, which would probably still be kind of large, it would have to be, I mean, even if you collected all the sun hitting the earth, you know, it's like enough energy to, you know, light a big city or something. It's just not, it's not that spectacular an amount of energy. Solar energy just isn't all that powerful. And you have to think about the reason why fossil fuels is because they're, you know, an ounce of oil might represent 1,000 or 2,000 years of solar energy hitting a square meter of surface on the Earth. It's stored over a huge amount of time that energy was collected. So it's a lot of solar energy in the oil. Anyway, would be enough for me to, okay, which is probably still kind of huge, would be enough for me to dedicate a vast portion of my life, health, and assets to promoting your channel. Oh, so if I promise you free energy or something, you know, yes, this I can make a piece of chalk, and all you do is lick the chalk, and it's like a battery for life. That's all you do. It's really easy. Just look at it. No. Sorry. I'm just saying that, you know, real physics isn't going to get you free energy beyond the description of where you can get a lot of energy easily as breaking atoms. But the problem with breaking atoms is you got to be really careful how you do it, or you break too many. Anyway, and they create a lot of radiation, you know, little broken photons. Playing with little broken photons can get you into trouble. Okay, anyway. Health and assets to promoting your channel, or brand, or cause. Yeah, it's just, you know, this is supposed to appeal to me. Sorry. Of course, I'd get involved in financing that very experiment as well. So let's just reduce the conversations to some crass kind of crap. What's in it for me? Blah blah blah, and all that kind of shit. I mean, I'm certainly in this game for some personal reasons, in the sense that, well, if I thought there's nothing I'm going to get out of it, if I'm right, like no enhancement of my credibility, no enhancement of my authority in the world, you know, my ability to have a conversation with something other than you trolls, then yes, I wouldn't be doing it. I wouldn't waste my time, because there really isn't anything. The only thing essential to this is just the recognition of how frail human intelligence is, and how easily broken it is by wrong assumptions. Just how bad it is to get a wrong idea in your head and to build new ideas on top of wrong ideas. Building on top of wrong ideas is just the definition of failure. And those are kind of life lessons, or memes, or something that people need to be more aware of. So that would still be a valuable thing to give the world, is the notion that you just can't trust mathematicians. You can't trust intellectuals, because they can be just as crass in their motivations as dumbasses. They can be just as full of shit. You have to do some of the hard work. You have to be ever watchful, or whatever the saying from the past is. Careful, cautious. We should be moving cautiously into the future, not recklessly. Wondering what you have in mind when you say set up multiples of to degrade photons enough. Yeah, so he's just basically saying break photons in half. Yeah, because now you've made invisible energy rather than visible energy. But yes, it doesn't really have much value. Do you mean to create a region or deficit of surplus force of both? Yes, the superior mind always makes it a little more complicated. No, I think I've accurately defined what he means. So we shall move on. So just another example. I mean, all you people are just kind of so disappointing. Okay, so, you know, the perv action guy wants to talk about crass materialistic nonsense, and then this Bob the Fly guy, who's supposed to be paying some attention, is gonna just do something insanely stupid. Okay, anyway, it is a good video title, Gary. So I don't know what the title was, something like Piro's an asshole, but I don't know. Okay. I would like to hear more about your thoughts on how simple mechanisms lead to induction. We've already done a ton of videos on the simple mechanism. It's charge. Charge leads to induction. Okay, there's two kinds of force, two kinds of matter bits, and they're inverse in their function. I'm not going to draw it again. We've already done this. Anyway, I have an easier time with the gravity concept using simple mechanisms. Well, again, gravity is a little subtly more complicated in the sense that gravity is fundamentally the only thing moving are the charged pieces. They're the ones moving, electrons and protons, and the neutron's made of electrons and protons. So I mean, it's all just charged bodies being moved by fields that are changed in their charge based on the fact that the electron has a mirror that's exactly the opposite of the proton mirror. So the electron reflects red light, the proton reflects blue light, kind of thing, and that has a huge consequence in their arrangement. But the force basically is purple, okay, and the charges separate from the purple, the blue, and the red. So gravity is in a sense more complicated, even though it looks less complicated. It's more complicated in the sense that it's just motion, it's just moving things, but it's moving a bunch of magnetic poles essentially that are all in different directions, and when they're all in different directions, the polarity disappears. So it's just purple being filtered by purple, so there is no filtering, but there's still the absorption of momentum. So I don't know how to put that simpler. The filtering doesn't escape. The filtering happens inside the atom still, but it doesn't go outside of the atom. So it's still a charge that's actually moving the electrons and protons, but it's not charge in the sense that the whole body doesn't in any way reveal that interior of the atom. I don't know how, some other way to say it. Well, anyway, that's probably good enough. Using simple mechanisms have you had explained extremely well in the past. And well, again, it's not that simple in terms of you have to understand. See, it's simple if I just draw a shadow and say, there, that's how it happened. This shadows this. But as I've pointed out, it's more complicated because you don't fall into the gravity, the shadow you're making. The shadow you're casting isn't the shadow you're falling into. You're falling into the shadow the ground is making. Okay, the shadow that's being cast on you already by the ground, by the earth. So it's a little more complicated. One note on gravity model that I am stuck on, though, is the lack of drag. So one video ago, it has the word drag in the title. I actually say a little more on the subject of drag or something. Leading to, I don't know, deceleration in the orbit of planets around the sun. Yeah, well, I've already explained it. Yes, there's a real concept. Drag is a real thing, and I just explained how you can make a little tiny motor by pushing energy into one surface, right, and the two surfaces move together, and how the forward motion would be eternal in a frictionless environment where there's a real exchange of energy, and the element, the ping pong ball, never loses momentum. So if you have something like a photon that doesn't lose momentum and you trap it, you can make a little engine out of it that just keeps pushing forward. And there wouldn't be any, it would overcome the drag with its engine. And the more drag you created, as I pointed out, right, if there is a real drag problem, it can't matter, because that means you've given the thing more time to move forward, because it takes longer for the photon to go the opposite direction. It's allowed to travel forward longer the more drag I create. So it'll move slower, but it'll still move the same distance. So the drag is negated because it's dragging the backward wall, And by dragging the backward wall, you give the forward motion more time. So, I mean, I already explained it. So I'm just disappointed. You know, the video's just a video ago. I mean, anyway. Drag leading to deceleration in the orbit of planets around the sun. I would think collisions would produce a deceleration that would cause a decay orbit. Thanks again. So, I mean, I've already acknowledged the fact of it. I've used the word drag, 100 times or more. And I've explained that, yes, it would be a real phenomenon, but obviously the universe takes care of it. There's a reason why you can overcome the drag. And the reason is, if you have some object where you've trapped the energy in, the forward momentum is always preserved, conserved. So if I throw something into a trap in one direction, the fact is that direction is conserved. And so it just keeps moving in that direction. So as long as it doesn't fall out of the trap, there's no drag. But whatever. Like I said, I already went to the trouble to explain it. And he's saying like he didn't even see it. Well, fine. You didn't see the video. Sorry. I keep asking him to produce, this is on another Ken Wheeler video. So this is probably a troll, probably with sock accounts. I keep asking him to produce peer-reviewed paper. I don't think you can keep asking Ken Wheeler that, so you're a liar. So what's the point of view? Ken Wheeler won't allow you to keep asking him anything. That doesn't happen, idiot. That supports any of his theories. His theory is he's acknowledging the existence of stuff. Now you're saying there's no peer-reviewed paper supporting what? Hyperboloids? Well, I don't know. I'm not sure of that. There's no rational science defending any notion of Faraday's arrows, okay, or Maxwell's arrows, pointing that like the force moves in a direction. There's no evidence that the force actually moves in those directions. The only evidence exists is that there's an even pressure produced by a charge or by a magnet. The field lines they see, okay, with iron filings, are not a representation of a force moving along those lines. There's just no evidence of any pressure in those directions. So what you haven't seen, well, I can tell you what I haven't seen. I haven't seen a single experiment ever where they put anything around a magnet and got it to swirl around for free, because it doesn't happen, because there's no current there, because there's nothing moving around the magnet. The magnet is radiating force. It is not creating force that swirls. Just that you don't have any real evidence that there's anything in an atom that's swirling around the atom. You don't have any real evidence of that. Lots of papers talk about it, but talking about it and demonstrating its existence are two different things, and they've never demonstrated it. They say that there's a spin thing in quantum mechanics, and they'll admit, well, we don't mean it's actually spinning. What good are peer-reviewed papers in this context? I mean, realistically. They're allowed to talk about things that have never been demonstrated to exist all the time. They assume lensing happens, gravity, photons are bent by gravity, and they're not only bent by gravity, but they're bent twice as much as any other object in the universe. So the special photon is somehow bent twice as much as the electron or the proton by gravity. Is there any rational reason to believe that's true? Does it make any sense in some sort of model way? No. They just say so. And they say so based on putridly thin evidence. So, oh, fuck you is all to say. There's nothing else to say. Fuck you. Alright, but on the subject of the claims of physics, there was something I was thinking about, just because they keep calling it particle physics, and they don't really believe in particles. And the particles they've found are just so without reasonable properties. It has 1/4 spin, some other kind of silly talk. So I was thinking, that there's got to be a better way to understand with their evidence. And much of their evidence is this idea that you have a cloud chamber, and they can see events. They see something go this way, and they see something go this way, and then something forks off of this like that or something. So they see these trails, and often, these trails don't even have something that comes in. So all they see is this part. It just has this pointy part. And they make some assumption that whatever's flying through here, somehow it's going very, very fast, and somehow whatever it is, it must not be charged, and that's why it doesn't leave a trail. But it's only charged things leave trails. And that's kind of, you can just say off the top of your head, it really wouldn't matter whether your bullet is an electron or a proton, right? It's a bullet. So that it should be visible and all that kind of stuff if it was a real particle. So the idea might be is that all this stuff is rays of force that come in, like something explodes, a nuclear bomb or something, and it's creating it's releasing all kinds of things from springs. So essentially there's a bunch of, you could think of the atom as being a bunch of springs that are really contracted, And when you break the atom, all the springs shoot, they expand quickly. And when they do that, what they're really doing is just pushing a bunch of the little force bits. They're giving back a bunch of energy. Okay, so it's sort of as I pointed out with the electron. It makes a whole bunch of exchanges in a direction. What that means is essentially shoots a bunch of energy in the opposite direction. So you could say that, if it's in a deceleration is basically just giving back what you had to take. You can't decelerate if you never accelerated kind of argument. But the point is those electrons can have the stored energy inside of them. And what they really do is they really have to exchange. So they could have 10 bits going this way, and they could exchange it for 10 bits going the opposite way. So they could take out of the field 10 going this way, and they could give all of these back in very rapid, just almost as a whole collection. They could give them all back. And that would be sort of a photon. But it'd be a high energy photon because all the arrows would be really close together. And so that's what this stuff could be. It's not a particle. It's just a ray of force, and it hits a particle. It hits something inside of an atom, an electron, and when it does that, it does the same thing in reverse, in the sense that now it's going to accelerate an electron. So it's going to do the same thing. It's going to basically give its energy, its arrows, to these parts, and it might give 7 to this bit, it might give 3 to this bit. All right, so and so now this thing is moving, this piece of electron, and it hits something with its momentum, and now its momentum will be divided. But these divisions might just be the energy, frankly, going from atom to atom. So like in a plasma, there would always be this idea that if you shoot something through it, it lights up. And that's why we're seeing this trail, is because this is just energy that went this way. It wasn't a real electron or proton. It was just more of these little rays traveling at a speed where they're going to create photons. Because you have to sort of jiggle electrons to create photons. You can't hit them too hard, you can't hit them too soft. That's why only certain frequencies of light create photons, excite the material in a way where it creates photons rather than other forms of radiation. So anyway, so it's nothing I don't have any hard point to make, except that what they're calling a meson or a tau or some other kind of bullshit is really just this much of a ray of stuff very, very close together. Very high frequency of energy, photon, a very high frequency photon of variable length. The longer it is, the longer the amount of little bits, the number of cannonballs, the more it can do, the more it can be subdivided. So the probably not particles at all. And that's why they don't have a half-life. See, they're measuring half-lives of something. See, I could argue, I think I can, reasonably argue that, when this stuff comes down from the atmosphere, these muons and stuff, they're really not hard bodies. They're just energy. And when they say what's the word they use for the decomposition? Decays. Okay, the decay isn't the muon decaying. Decay is that it's hitting stuff, and as it keeps hitting stuff, it's becoming more and more. Its frequency is becoming longer and longer because as it hits things, it's interpreted by them like electrons can do. So it goes in at a very high frequency, but it comes out in a lower frequency, and so you're finally getting to a frequency where you can create a visible photon, and they're calling that decay. But nothing really decayed. The force just finally became it was finally interpreted through enough matter. It hit enough matter where through the process of hitting matter, its frequency was reduced, widened, so it went from really, really close together to much wider, and eventually it makes something we see, and we call that decay. But it's just the process of the energy moving through a bunch of atoms. And that's why I can go through 3 feet of iron. Okay, realistically, it's because it's really hitting the iron, and in the process of hitting the iron, the frequency of the energy is being lengthened, and now it can do something we can see. So now when it hits something, it's not going to be invisible to us. It's sort of like the speed of sound. I mean, that's a whole nother subject to get into. But I mean, the motion for the speed of sound is you can't have motion that's too fast because it won't be recorded as sound. It'll just turn into heat and expansion of the medium. So the only way you can have something called sound travel is you have to push atoms into each other. Just where the atoms exchange the momentum. But if you push them in too far, too fast, they don't do the cue ball thing. They don't behave like a pool table billiard balls. They don't hit each other and then go like this. If you put them in too fast, well, then both of them move, and things that happen, they go sideways. Things happen that aren't going to create the transfer of the energy, the efficient transfer. So the efficient transfer happens when you push the pillow against the pillow. The electron pressure pushes against the electron pressure of the other atom, and the electron pressure pushes the atoms apart. But if you go in too hard, you hit something other than the electron pressure, and you hit the protons and other stuffs, and that causes atoms to move in directions that aren't going to be, creates heat and other things. It's not going to move the vibration through the mechanism. And the same thing happens with these high energy photons, is they don't create the vibration, the movement of an electron, the right amount of distance to have it come back again. They knock it out of the atom, or they do something else more radical. And if they knock it out of the atom, we don't see it. There's no visible impression. But if they move it out of its position and the electron moves back, then we'll see the photon. Okay. Probably enough. Alright. So anyway, it's just so tedious. Yeah, that's what it is. Tedious. So anyway, I mean, it's look, we've really made a lot of progress. Got a good definition of polarization, charge, magnetism, and gravity. So, lots of good news to report and such. But till the next time, and so forth and whatnot.